Welcome to Nottingham British School, the home of science, maths and technology. I'm Dr. Zia Zamir, and today we are going to talk about the scientific method, the steps, the terms and the examples.
The scientific method is more than a hypothesis and experiment. In this lesson, we're going to explore the themes and variations that make up the world of science. So I've got a question for you. Is there only one scientific method? Well, when you first took science in your class a few years ago, you probably learned the basic steps of scientific investigation. You've likely heard of words like hypothesis, experiment, observation. You may have even memorized a prescribed set of steps. The scientific method is a set of procedures that scientists follow in order to gain knowledge about the world. However, the steps involved in the scientific method vary widely among the different scientific disciplines. Chemists follow the method a bit differently than psychologists. Geologists have their own unique methods. So, is there really one scientific method that encompasses all of science? Well, to find out, we'll need to learn more about the scientific process. So the key elements of scientific method. There are 6 key steps that tend to categorize the scientific method. The first step is the question. This is the part where the scientist proposes a problem that he or she wants to solve. A well-conceived question usually leads to hypothesis, a potential answer to question at hand. Sometimes hypotheses look more like predictions. The scientist predicts what the outcome will be when he or she tests the hypothesis. The scientist's test is also called the experiment. Experiments are ordered investigations that are intended to prove or disapprove hypotheses. Important data comes from performing an experiment. The scientist has to make observations of results that he or she gets from an experiment. An observation is a statement of knowledge gained through the senses or through the use of scientific equipment. Observations are crucial for collecting the data. Once results are in, the scientist must begin the analysis. Data analysis involves comparing the results of the experiment to the prediction posed by the hypothesis based on the observations he or she made. The scientist has to determine whether the hypothesis was correct. He or she then sums up his or her findings with a conclusion. The conclusion of a scientific process is a statement of whether the original hypothesis was supported or refuted by the observations gathered. The scientific method usually employs all 6 steps mentioned, but the steps don't always occur in the same order. Real scientists may go back to repeat the steps many times before they come up to a conclusion. It's actually better to use the word elements to describe steps, since the first step, question, does not always come first. Sometimes, for example, it's an observation that came first spawned the initial question. Likewise, observations that are made during the experiment can inspire more questions the scientists have to answer. The scientific method is much more fluid than you might think. Let me show you how the steps can feedback a branch out from one another with an example of my own experience. I.e., let's have a look. Last week, I got let's just call it the feedback loops in a scientific method. So last weekend, I had a minor audio with my internet connection at home. I started up my laptop and I was frustrated to find that I couldn't get on the internet. I made an observation that my laptop wasn't receiving an internet connection. So I asked myself a question: is something wrong with the internet itself, or was it just my laptop? One way to begin answering this question was to check the connection on the desktop computer. Quickly I formed a hypothesis. If the internet isn't working on the desktop either, then the problem is beyond my laptop computer. The experiment I performed was to check the desktop's connection, and my resulting observation was that the internet did not work there. So by analysing the evidence, I was able to form My first conclusion: nothing is wrong with my laptop and something is wrong with the internet connection. Get it? Right. Now, this conclusion answered my first question, but it still didn't get my internet to work. So I had to pose another question. Where exactly was the problem occurring in the chain of internet devices? Was it the cord between the modem and the router, the cord between the router and my computer, or was it the problem in the router itself? I had to form another hypothesis. If both my internet cords are probably plugged in, then there must be a problem with the router. My experiment was to check both cords on the router. My observation was that both cords were plugged in and the router was off. I analysed the evidence and my conclusion was that I couldn't connect to the internet because my router was off. So, girls and boys, are you actually seeing a pattern here? Once I came up with one conclusion, it left me with another question that I needed to answer. From every question I got a hypothesis, from every hypothesis I got an experiment, and from every experiment I got an observation that led me to more conclusions. I don't need to tell you the rest of the story. Eventually, I figured it out and my router was unplugged and solved my internet problem by plugging it back in. The important thing to see here is that the scientific method doesn't follow a straight line. It loops back on itself in countless ways. It branches out to new investigations. There is never just one way to answer a question in science. So we have fluidity and community in science. Okay, I'll explain. Keep in mind the elements of the scientific method are not only things that keep science moving forward, it is not nearly as rigid as many textbooks describe. In addition to hypotheses, experiments, and analysis, science requires more subjective processes like creativity, experiment, and initiation. In my problem with the internet, I needed to reference back to my basic knowledge of computerized technology. I knew from the experience that unplugged cords were most likely cause of the problem, but I also brainstormed for a minute or two about the possible causes. Well, other possible causes, let's say. I have 2 curious children and a wife who often changes the arrangement of our cords on the power strip. It's dusty under our desk and the router is getting old. Any of these factors could affect the connection. I didn't end up pursuing those other possibilities, but what I did was use plenty of creativity while trying to solve my problem. If it had turned out that my problem was more complicated than an unplugged cord, then I would have to have a handful of other ideas to try. Many scientists have used combination of skills to develop their ideas. Take Charles Darwin, for example. Not someone who I believe, but let's talk about him anyway. He is credited with devising the theory of evolution by natural selection. It's a biological theory, but Darwin wasn't a biologist. He was a naturalist who studied not only plants and animals, but anything to do with the natural world. Darwin read up on geological principles written by Charles Yale. He studied theories of economics and population by Thomas Malthus. He bred fancy pigeons and collected nature artifacts on his farm. And yes, he took an amazing voyage to study exotic creatures around the world. Darwin wouldn't have come up with his ideas about evolution without combining all of these influences. It took some creativity and 20 years of research to put all his ideas together. Darwin's work shows that scientific method is really a fluid, integrated process. Not which one I agree on, being religious and being a Muslim, but there it is for all to see. It's worth mentioning that scientific studies are kept in check by communities around the world. Most scientific journals employ a process of peer review, whereby scientists critique each other's work and decide whether it meets the standards of the scientific community. I.e., if you subscribe or look at one of the most popular books that I look at is The New Scientist. Scientists have to pool their resources and check in with one another before they can perform any significant work. But scientists also compete with one another to discover new things. They know the prize goes to the scientist who gets things right and publishes it first. Even Darwin had to compete with other naturalists like Alfred Wallace, Jean-Baptiste Lamarck, but he also worked closely with his friends Joseph Hooker, Thomas Huxley, who studied biology and helped him develop his theories. As you can see, the scientific method does not work in isolation. It functions within a community, both inside and outside the realms of science. So, let's talk about this lesson summary. So it turns out that really is no one way to follow the scientific method. There are key elements that should appear in any investigation, but science is done differently in every profession, and no one follows the exact same process. Remember that, no one follows the exact same process. The scientific method describing processes by which scientists gain knowledge about the world is characterized by 6 key elements. Now you need to remember these, yeah? Questions, hypothesis, experiments, observations, analysis, and conclusions. These elements are interrelated steps, so they don't always function in the same order. Other more subjective skills like creativity, experience, intuition also have a place in the scientific method. Science is characterized by professional competition and develops through the collaboration of scientists in the worldwide community. Okay, and that's the lesson for today.